I hear a lot of talk about dependency injection, where it seems like a really complicated concept. But it totally isn't. I want to show you what it is, and with a good example and some code, and then you'll see how it makes our systems more flexible and more testable. One class depends on another when it uses the other to get the job done. The pattern for dependency injection calls the class that is using the dependency the client, and the dependent class the service. That denotes that the client is using the service to get their job done, not that the client is a client in the usual client-server terminology. You can see the dependency here. The client contains an instance of real server and presumably calls give help in order to complete get the job done. Dependencies can be a source of trouble. To me, the most obvious trouble is that I can't test the client without also having real service fully built and fully functional. And if my tests on get the job done fail, I'm not sure if the problem is in the client or in give help in real service. With this design, we have tightly coupled our client with the service. If our requirements change and we need other ways for give help to work, we'd be in trouble. To make this point, suppose that we're building software for a credit card company. The credit card class processes each transaction for a particular cardholder's card, and the service knows how to calculate their cash back. With this design, all the cards would have to have the same cash back rules, and we know that's not true. We'd really like to have a variety of services that each calculate the rules every which way our various cards need. And then we'd like each cardholder's card to get the service that's right for their card. Dependency injection is going to fix this for us. This is the most basic version of dependency injection. And we could say this is the strategy pattern. We have multiple concrete services that all implement the service interface. The constructor of client takes a parameter that is a service, and it uses that to get the job done. For our credit card example, we would have a bunch of ways to calculate cash back. And when we create a credit card, we give it the cashback calculator that it should use. Then, when we're processing a transaction, we use the calculator that we were given to update the cashback total for this card. This isn't really a complicated change, but it has completely decoupled the client from the service. We can build them independently, and we can put together exactly what we need for each card. And it has one other great benefit. Now we can test the client without needing the service. In this test, this anonymous class is a stub class that implements my cashback calculator interface, and I'm making it my cashback calculator. When I create the credit card that I want to test, I give it that object as the service it should use. Just to be careful, I'm checking that the cashback total starts at 0. When my credit card processes a transaction and calls calculate cashback, it will get the one in my anonymous class, so no matter what, the cashback should be added to the total is $12.12. Using dependency injection opens up a lot of testing techniques for us. Check out my video on stubs, fakes, mocks, and spies to learn more. Sometimes you want most objects to have the same dependency, so we want a default. We can set up that default in a no-arg constructor and delete the other constructor if we really want everyone to have that default. So I'm defaulting my credit cards to the 2% cashback calculator. If we also build a setter, then we can change the behavior on the fly. That's enough to be able to let us decouple things for testing. In my test, I can create a card with the default behavior and then use the setter to change the behavior. With this, all of the cards get that default behavior, but we can still use the stub to do the testing. That setter, which lets us change the dependency on the fly, makes room for the last piece of the dependency injection design pattern, the injector. This is a class that gives the client the service it should have. If we only set the dependency up in the constructor, the injector is essentially a factory that builds the client. For our credit card example, that'd be the factory that sets up the credit cards and it would know which cashback calculator the card it's building needs. However, with the setter, our injector can be a lot smarter. These days, credit cards change their cashback rules all the time. This month, there might be a cashback bonus for charges made at restaurants or theaters, and then next month, the bonus is at home improvement stores. And even if you look at one company, different cards have different rules, and bonuses are starting and expiring all the time. For that situation, the injector would know when a new calculation is needed. It'd find all the cards that need their calculation updated and use the setter to change it. Yes, this is a little unrealistic because most cards aren't in memory at any given moment, but it shows the flexibility that dependency injection gives us and how we could leverage an injector to change the dependencies at runtime. So, dependency injection is the best thing since sliced bread. It makes our system adaptable and testable. Should we use it for everything? Take it to the extreme. That would mean that every class needs a separate interface so that we could substitute a different implementation if we wanted to. That is certainly overkill. So, how do we pick where we should do this? My first clue is the design principle: separate what changes from what stays the same. If there's a part of your system that has multiple ways it can be done, or that you believe will need to change over time, that's a good place to consider dependency injection. My second clue is testability. If there's a critical part of your system that depends on something that is complicated, dependency injection would let you separate them and test them independently. This can be particularly useful if the dependency requires a connection to an external system or a data source. Separating that so you can test without that dependency can also make your tests run much faster. My third clue is development schedule. If I need to be able to demonstrate a minimally functional client in my minimum viable product, but the dependency class is really complicated, I can use dependency injection and build a simpler version to get things started. For example, in my credit card system, I could start with all cards getting 2% back no matter what. Later, I can build more complicated cashback policies and add them to my system without changing the credit card class at all. So dependency injection is a way to decouple a client from a specific service that the client uses. The result is a system that has much more flexibility and is much more testable.